So in the last video, we were working on this problem and we got through the first part of it. We found a lambda value that allowed us to fit this specification for our function that it would remain as close to 1 as possible when x is near 0. And we found lambda to be -2. And then we rewrote our function under that lambda value. And here's where we are now. And what we want to do now is using this lambda value under our function here, we want to estimate our function at 1/10 to 2 decimal places. So that's what we want to do in this video. So pause the video and given this here, try to do that. All right, assuming that you've given it a go. Again, I think it would be nice to just remind ourselves what we did in the last video, just a little bit. So let's scroll down. This right here was our linear approximation, and we found that lambda was -2. So if we were to write out our linear approximation in the form that we're used to, so this was for x values near 0, we found that f of x was approximately 1 minus 2x, and then minus lambda x. Lambda was -2. So again, this was plus 2x. And not surprisingly, this is 1. So this is a tangent line. Y is equal to 1. And we use that for our linear approximation to approximate values of this function near 0. That's exactly what we did in the last video. So how does that relate to what we want to do in this video? Well, it tells us that we can't use a linear approximation to approximate 1/10 because it wouldn't be to 2 decimal places. We need to have a better approximation in order to get some more accuracy, to get to 2 decimal places. So we have one other tool for that, and that is a quadratic approximation. So what we're going to do in this video is make a quadratic approximation for this function here for x values near 0, and then use that to estimate our function at 1/10. So let's do that. And again, similar to what we did in the last video, we're going to call up what we've been learning because this is a product of 2 functions. And for quadratic approximations, we can either take the quadratic approximation of the product of the 2 functions, or we can find the separate quadratic approximations for each of the functions and multiply them together. And in this case, tossed out some higher order terms. And again, like I did in the last video, I'm going to opt for this over here, this side. So we need to find the individual quadratic approximations for e to the 2x and 1 plus 2 sine of x to the -1 power. So again, pause the video, give that a go. All right, let's start working on these. So we know for x near 0, that e to the x is approximately 1 plus x squared over 2. So if we want to find e to the 2x, well, we just substitute every x we see with a 2x. So we have 1 plus 2x plus 2x, that whole quantity squared, over 2. And we find this to be 1 plus 2x plus, and then we have 4x squared over 2. So that's going to be plus 2x squared. So one of those is done. So now we can look at this guy over here. So maybe I don't want us to get lost in notation here. Let's see. This guy here, from the last video, we called that guy G. So we'll call this guy G as well. So this is Q of G. Okay. So again, we just need to find 1 plus 2 sine of x to the -1 power. It's quadratic approximation for x near 0. So let's work on that now. So for x near 0. And if you can remember from the last video, we said that with linear approximations, when we have this guy here, we know what the linear approximation of sine of x is, and we know what the linear approximation of 1 plus x to the rth power is. And can we do that with quadratic approximations in this video? Well, yes, we can. So again, we're going to find the quadratic approximation of sine of x, and then we're going to plug that in and find the quadratic approximation of what that thing that we get back is. So here's what that looks like. So sine of x for x near 0 is approximately x. And then we plug that in. So we plug that in up here, and this becomes 1 plus 2x to the -1 power. And then we find that quadratic approximation. So again, for x near 0, we know what 1 plus x to the rth power is. It's going to be approximately 1 plus r times x plus r times r minus 1 over 2 times x squared. So now that we have this, again, if we want to find 1 plus 2x to the negative 1 power, wherever we see an r gets replaced with a negative 1, and wherever we see an x gets replaced with 2x. So filling that in, 1 plus negative 1 times 2x plus, and then we have negative 1 times negative 1 minus 1 over 2 times 2x whole quantity squared. So now cleaning that up, that is 1 minus 2x. And again, just a good check. We found that in the last video. That is the linear approximation. And then continuing here, we have a negative 1 minus 1 is negative 2 times negative 1 is 2. So 2 over 2 is 1. So we're left with 4x squared. So plus 4x squared. That is our quadratic approximation of h. It's q of h. And now what we need to do is multiply these guys together and throw out some higher order terms. So let me continue to divide this. Don't want us to get lost. Here we go. We're coming to a close here, folks. Let's finish strong. So let's see. We have q of g, q of h, and all of that's going to be equal to, we want to multiply these guys together. So 1 plus 2x plus 2x squared, and then multiplying that by 1 minus 2x plus 4x squared. And then maybe I can grab a little more space. There we go. And then multiplying these guys together, we get, let's see, 1 minus 2x plus 4x squared, and then plus 2x minus 4x squared. And then remember, we want to toss out the higher order term, so I'm just not even going to write them down. That would be a cubic term, and then we have plus 2x squared, and I think that is the last term. So we see that, what do we see? We see that these terms here cancel, so do the 4x squareds. So we're left with our quadratic approximation is 1 plus 2x squared. And maybe I can write that in the form that we're used to. So we're saying for x near 0, f of x is approximately 1 plus 2x squared. And what do we want to do with this? We want to use this to estimate, 1/10. So let's see what that is. Oh man, here we go. So f of 1/10 is approximately 1 plus 2 times 1/10 squared. What is this here? This is 2 1/100ths. So this is equal to 1.02. So f of 0.1 is approximately 1.02. And you can see that is to 2 decimal places. So that is our answer here. And let's just review what we did. So we first found a lambda value in order to fit this specification that our function would be as close to 1 as possible for x values near 0. And then we took that lambda value and plugged that into our function and then came up with a quadratic approximation in order to estimate our function at 1/10 to 2 decimal places. And we found it to be 1.02. So that's the problem. And again, maybe you could see it. Like this combines absolutely everything that we've been learning about linear and quadratic approximations. So I thought it was pretty cool.